Thanks everybody for joining our March showers version of the AFCEA lunch. I'm glad you all could attend without having to pull out your umbrella. We've got an exciting lineup for you today. And before we get into that, I just want to give you some announcements of upcoming events. Tonight, we're having our second trivia night. There are 12 teams competing for bragging rights in our community. We also are excited to say we're going to be supporting a virtual NAPI, and that's on May 3rd and May 4th. There's restrictions on how many people can enroll, but check our event page for more information. We also have May 6th, our awards night. Invitations will be going out the first week in April, and I highly recommend you attend this night to see what we've done to recognize some outstanding students in our area, and through the generosity of your sponsorships, we've been able to give out some nice scholarships. And then I'm really looking forward to May 21st. We'll be able to be together for our spring golf outing at Compass Point. And then finally, I'll remind you, our next luncheon right now is scheduled on April 15th, which I'm happy to hear it's no longer tax day. We have till May 15th. We may end up moving that luncheon to a little earlier in the week to accommodate our speaker, who is Stu Shea, the CEO of Peraton. And with that, we'll turn it over to John Stressing and General Yee, who will discuss cloud computing with a panel that I can say our prep discussions were outstanding. And if it's anything like that, you're all in for a real treat. Over to you, John. You got to unmute, John.
Okay, here I am. Thanks, Gary. Hello, everybody. I'm John Stressing. I'm the Vice President of the Young AFCEANs for the Central Maryland chapter. I'm here today to introduce Major General Garrett Yee. Major General Yee is the Assistant to the Director of the Defense Information Systems Agency. In this role, he helps lead a global organization of 8,000 military and civilian personnel who plan, develop, deliver, and operate joint interoperable command and control capabilities and a global enterprise infrastructure in direct support of the President, SecDef, Joint Chiefs of Staff, combatant commanders, DoD components, and other mission partners across the full spectrum of operations. Prior to this assignment, General Yee served as the military deputy to the Army CIO G6 and senior information security officer in the office of the CIO G6 headquarters, Department of the Army and Pentagon. General Yee is also a veteran of Operation Inherent Resolve, Enduring Freedom, and Operation Iraqi Freedom. So without further ado, here is Major General Yee. Thank you for coming, everybody.
Hey, thanks, John, for the introduction. So on behalf of Lieutenant General Skinner, our new DISA Director and Commander of JPHE Doden, thanks for asking DISA to participate in today's AFCEA Central Maryland chapter event. I'll start by saying it's great to be back. It's hard to believe that it's been since September 2019 since we last connected with a luncheon or something like this. And so I do want to thank the Central Maryland chapter for organizing today's event. Special thanks to John for the intro and the invitation. Thanks to Al, thanks to Rebecca, thanks to Gary for putting this all together today. It is my first reappearance since September 2019. So I was beginning to wonder, that's 18 months, I was beginning to wonder whether or not I would get invited back again. And so happy to be back. And I did see a few familiar faces in the attendee window today. I think I saw Rick Norton and I saw Teresa Pine. So a virtual shout out to a few familiar names and faces that are in the session today. On a personal note, the AFCEA Central Maryland chapter is the one I'm particularly fond of because it is the chapter in our own community. And so, special thoughts and wishes for this particular chapter for being a community partner. I've been in the NCR since 2015, like 6 years now or so. And so I know I've crossed paths with many of you here on the call today. And so it's always interesting during these transition times though, and I've been through now 2 transitions during that 6-year window. And what we thought was a predictable way ahead becomes maybe not so predictable in terms of the way we do things and what are the priorities, et cetera. And we do know that the new Secretary of Defense issued some new priorities for the department. And of course, all of us in the Defense Department will be realigning our priorities towards that new set of priorities for the Defense Department. No major initial shakeups or anything, but that's how we do things here in the government, right? Now, last time there might have been a football involved. No football this year, Al. And last year there was a story about my daughter involved, how she thought it was a great idea to quit her job and travel across Europe for a couple of months before coming back and deciding to get back to work again. And she did, by the way, get a job after she came back from that trip. But today I will start off with a little story about my daughter, because today we're going to talk about technology, not just cloud. We'll be talking about, some things that may not be even, in production or possible today. But we want to talk about what might be in the art of possible, which is a phrase that we often use. So, a couple years ago, when I was on the Army staff, I knew I was coming to DISA. We lived in Old Town, Alexandria, beautiful place. And knowing that I'd be working at Fort Meade, we moved to Maryland. And I know my wife still misses Old Town, but we embrace and love Maryland today. And at the time, I would take the Metro to the Pentagon, and we were a one-car family for Maria and I. Coming to Maryland, we knew that we would have to get in the car. So our daughter, who, before she quit her job, worked at Tesla, said, "Hey, Dad, you should buy a Tesla." And at the time, I thought, well, I don't know, I was not paying attention to what was going on with Tesla. But I had always supported my daughter, whether it be Girl Scout cookies or school events. And so, okay, my daughter works at Tesla. Dad, you should buy a Tesla. So I bought a Tesla. Little did I know how advanced these machines are. These computers, it's a computer on wheels, right? And what's interesting to me is that it's not necessarily cutting edge technology that was used to put that car together and have it do what it does. It was leveraging existing technology to create a new way of delivering transportation electronically without gas. We've had that car now for over 2 years. I've changed the tires, 2 tires changed once, changed the windshield wiper fluid, and that's about it. And although today we see more and more electric vehicles on the road, electric vehicles are not new. And yet, if you drive an electric vehicle, and I'll say this from driving 2 years with my car, it's hard to go back. It's hard to go back because these vehicles are so, easy to drive, intuitive, and responsive for a very reasonable price. That for me, when people ask me what I think the difference is, why I say it's like, I used to have a BlackBerry, now I don't, and I have a smartphone, and it would be hard for me to imagine going back to a BlackBerry after having a smartphone for a couple of years. It's like that. It's that kind of a change. So what we're going to talk about today is the future of technology, and cloud's part of it. And why is it that sometimes we have a hard time, adapting or adopting new technology, even though it's available, right? Even though it's available. The car industry reminds me a little bit of the same challenge. There is new technology available, yet it's having a hard time, in my opinion, making that adjustment to become more, technology enabled, like a Tesla or other electric cars that are out there today. So that is what is on my mind. We have some amazing smart people with us today. We have Dave Brown from Microsoft, Josh Marcuse from Google Cloud, Scott Gaetjen from Oracle, and Hillery Hunter from IBM Cloud. And so we're gonna have a cool conversation today. We're gonna talk about what's on our mind. We'll talk a little about what might be on your mind, hopefully. And if you have questions, make sure you throw them in the Q&A box. But let's go ahead and start off with David. David, over to you.
Hey, good morning, everybody. My name is David Brown. I am the CTO in our Microsoft Federal National Security Group. I suddenly feel very self-conscious about the lack of pictures and frames on the wall behind me. But I'm really looking forward to this discussion. I've been at Microsoft 21 years, and as a commercial company, historically, Microsoft has built very broad-based products and services that apply to all industries. But cloud is allowing us to put together to more deeply engage with specific industries like defense. And like an obvious example of that are industry-specific certifications, or in the defense space, that's clouds at various classification levels. But there's a lot of other examples that I think hopefully we can talk through as we go through the day. And just to kind of pick one that makes a point that's less obvious, Microsoft has been using open source for many years. Not surprisingly, open source is good for business if you're a cloud service provider. Most of our customers in our infrastructure as a service are using some form of open source. Microsoft has built a number of platform as a service offerings ourselves based on top of open source services. And so one of the things our engineers have started doing are taking industry-specific open source applications, running them at scale in our cloud. And if they find bugs, fixing those bugs. If they find ways to improve the application, make it better take advantage of the cloud, we're going ahead and doing that. But then contributing those changes back to the open source community. So it's not only good for Microsoft, but hopefully it's good for anybody in that community who's running the application, regardless of where they're running it. And so a couple of days ago, we announced that we, closer to home, we had done this specifically for Apache Accumulo and Apache NiFi, and made significant open source contributions there. So again, thank you for the opportunity to participate, and I'm really looking forward to the conversation.
That's great. Hey, how about Hillary? Hillary, what's on your mind, Hillary?
It's great to be here today. And, as we were chatting a little bit before this panel, I said one of the things that I often like to do is to be a little bit cheeky and say, let's first make sure that we know what a cloud is. And I mean that less flippantly than it maybe sounds like. So I'm our Chief Technology Officer for IBM Cloud globally, and I get to work with our teams in the federal and public sector. I spend most of my time with clients that are looking to transform an enterprise, looking to transform an agency. And the topic of cloud, we sort of presume we know what a cloud is when we start talking about it sometimes. But if we really take a step back a little bit and think about it, I think there is sort of a next wave of cloud adoption going on right now. Around the time of 2015, 2016, everyone sort of said, go to the cloud. And you sort of said, wait, why? And everyone was doing it. And I think now there's a much more nuanced set of assumptions. There's value proposition around having elasticity. There is a need to have sort of a freshness of content that developers can create new capabilities and leverage what we as cloud providers are investing in and providing as a service-based capabilities and AI and all that other kind of stuff. And so the reasons to go to cloud, I think, are becoming clear, not just because everyone's doing it, but what the cloud is, I think, is such a fascinating conversation right now, and especially for this area, right? Cloud being a set of capabilities that can be deployed in a consistent way across a variety of operating environments, not just a public cloud, which is incredibly important, but also extending all the way out into the edge and all the places that, there need to be high functioning capabilities, AI, analytics, streaming data analysis. Cloud really and distributed cloud enables a conversation about consistency of all of those operations, consistency of security context, consistency of monitoring, consistency of vulnerability management, all those kind of things across all those different environments where IT needs to be taking place. And that's one of the things that I just wanted to kind of, provoke here on this panel as a potentially interesting discussion.
Hey, thanks, Hillary. So what is a cloud? Okay, we'll get back to that. All right. All right. Hey, Josh, over to you from Google. What's going on with you at Google? I can almost hear you, Scott, but you might be muted.
There we go.
There we go.
All right, that's got it. We have helpful moderators keeping us in line. So what I wanted to say was, I'm just thrilled to be here. Grateful to you for having us, and I think we just need to have a lot more of these sort of cross-industry public-private conversations about these emerging technologies. And I love the frame that Hillary put on it. For me, I spent my entire career in DoD and have been, supporting the warfighter and the customer that experience, and came to Google only a year ago. And I think for us, a perspective is to take that same passion for the mission that I and a lot of my colleagues who are former public servants or veterans had when we were in uniform or in the Pentagon every day, and figure out how to use Google's technology to aid that mission. And so we're really come at this not from a technology centric perspective about what our cloud does, but really from a mission centric perspective about, what does our government customer need? What does the public servant need? And what do we have in our arsenal of tools that we can deploy to help get that achieved? And I'm really excited to have that conversation with you today.
Hey, thanks, Josh. When having spent 4 years in the Pentagon before moving over to DISA, I will say that I appreciate my time at the Pentagon. I am thankful for the experiences, and I'm really happy to be at DISA. So, all right, feel for you a little bit there. David from Microsoft, over to you.
I think we did me.
I miss Scott.
Yeah, I think you missed Scott.
Scott from Oracle.
Hey, welcome everyone. I'm glad you could attend. My name is Scott Gaetjen. I'm a Chief Cloud Architect in Oracle's National Security Group. We are an organization that of hundreds of cleared professionals that serve the military and the intelligence community. And it's an exciting time for us in the National Security Group because we're now offering FedRAMP and then our national security regions for classified workloads. And what I'm excited about is, if we look at, the mission today, right? I mean, there's there's a battlefield, or, if you're researching an adversary, right? There's sensors, there's full motion video, there's, drones. I see, autonomous vehicles entering that picture. I see robotics, in that picture. And really what you need to make use of that technology and all that data is hyperscale computing, right? And I think one of the exciting things is that, HPC type computing has become mainstream, right? You can stand up a cluster of, of hundreds, if not thousands of very high performing computers in a hyperscale cloud. And the other part that I think is really exciting about that capability of hyperscale supercomputing is that you're going to start to see predictive analytics and anomaly detection type AI and ML become mainstream, right? And it's really moved out of kind of a research activity to something that's being embedded into analytical services, right? And so the subject matter expert doesn't have to be a subject matter expert on AI and ML, because vendors are embedding those technologies in the tools themselves. And I think what they're also going to do is enable autonomy within the IT infrastructure. So not just IT, autonomy in the sense of, self-repairing, self-tuning things, but autonomy in people, in the people and the processes around the usage of that technology. So can I predict when a warfighter or some of the workforce is having a bad day or doesn't feel good, right? Those types of AI and ML applications, I think, are really exciting advancements that the National Security Group is really eager to assist with. So.
Well, thanks, Scott. So we made it through our round of highly esteemed panelists today. Almost double tapped David twice, but put me on track to make sure we didn't miss Scott. And with that, maybe we'll start off with something that you said, Scott. With autonomous driving vehicles, and we know we have land vehicles, aerial vehicles, and marine type vehicles that are autonomous. And here's a very basic question I think that maybe our audience might appreciate. How does, in a very layman's terms, how does cloud enable a land vehicle, aerial vehicle, sea vehicle, you name it, to be autonomous? What is the connection to that? Who wants to dive on that one there? Maybe Scott, since you brought it up.
Yeah, well, I think what it is is really it's the volume of data that those autonomous vehicles output, right? I think my wife's Tesla. I think somebody said that it does like a petabyte in maybe a month. I mean that's a lot of data, right? But I think just being able like I said, the hyperscale of the cloud, right? Having the ability to run up a cluster of HPC, right, for a particular mission, right, and then being able to do predictive analytics within that data set, right? And I think that's really how, kind of one of the key drivers for enabling the autonomous vehicle to do its work, right? I mean, a lot of it's on the edge, but some of it can be, situational in the cloud.
So great point. There's another thought you added to that, and that is, the importance of edge computing in all of this. What is it? What is the right balance? Who wants to dive on, that topic of edge computing, how that enables an autonomous vehicle?
Well, Garrett, before we jump to edge, which is a super important part of this, I also wanted to just answer your question real quick in a way that is really unusual, I think, for our conversations, but really, really important. And that is, that Tesla that you so vividly described was engineered in the cloud. And if you talk to Tesla engineers about their design process, it is inconceivable that either a SpaceX rocket or a Tesla car could have been designed without the cloud-based tools that they use to build the digital twins of that car, the machine learning they use to test the code in that car, all the things that make these new tools, from the smartphone that you described to the Tesla you described, possible to engineer, is the digital engineering that comes from a cloud native design environment. And so I think, when you talk to us in the industry that are really focused on selling our cloud services and our productivity services to a DISA customer, we think about it in terms of the sort of the government hardened version of the commercial service that a consumer uses. But in the military application, the equally important is all the research and design and development, the R&D, all of the stuff that is changing the way the defense industrial base thinks about the way it serves the military mission, which is about really bringing cloud all throughout, permeating the industrial base, so that your ships, tanks, planes, and all of your systems are also cloud native. It's not just about cloud for the human user. It's also the machine to machine cloud. It's such an important piece of the autonomy issue that Scott raised. And I just want to broaden the aperture to include that too. And then let's talk about edge as well. So I loved the question you asked.
Yeah, your mind went exactly to the same spot as mine did, in the sense of, there's kind of, when we're talking about data intensive things, there's the process that we often call training, right? So there's the process of creating something that has intelligence, in quotes, obviously, but the process of training something, creating models that are very capable. And that's where, the public cloud-based capabilities, those hyperscale capabilities, as they were mentioned, just really shine, because it's tons and tons of math. It's number crunching to the extreme, and it's lots of data, because the more scenarios that you're training your types of models and things like that on, the smarter they're going to get, the more effective they're going to be. And then out in the field and out at the edge, it's a different thing. You're trying to use that model. You're trying to do what's usually referred to as inference, right? And you're trying to understand your environment, and you're using all that learning, but applying it real time in those scenarios. And I think that's where, this conversation around, distributed cloud and consistency of cloud and consistency of your IT becomes really interesting, because the public cloud has a role in the place of creating capabilities. And then, within an individual, vehicle or other capability out at the edge, there needs to be a freshness of that content. You don't want those vehicles or those edge locations to become stale relative to the latest and greatest in learning and such that you've been able to derive in the cloud. And so you want to be able to constantly push and pull back and forth, but yet acknowledge data gravity, acknowledge that you don't want to be shipping all that edge data back to the public cloud all the time. And so it kind of becomes a hierarchy of cloud capabilities, and distributed cloud can enable that consistency and capability, and a platform for cloud can enable that consistency and capability, and keep things fresh at the edge. Enable perhaps some edge data centers, as an example, small cloud, mini cloud locations, so to say, that do some aggregation and then do, the big number crunching back in the public cloud, similar to, what you would call big iron and HPC.
I think I've just learned a new term, Hillary, data gravity. Maybe that's familiar to you all, but that's a new one for me. So
yeah, I mean, what I mean by it is that, data really kind of has a gravity, like a gravitational pull to it, in the sense of like, you want to align your computing and your data, because otherwise you're just wasting a lot of energy and time moving data around. And so collecting together large data sets that are useful for training models to be really effective in one place, like a public cloud, and doing the compute on it there, all that learning there, that training there, but then acknowledging that, there's a gravitational pull to data at the edge, right? There's this attractiveness of all those sensors and video feeds and everything like that. So you kind of want to take the compute and put it out there too, because there's a richness and an interesting amount of data out there. So I refer to, data gravity kind of as the, there is a pull of compute to where the data is. And I think that's a really interesting aspect in this whole thing about how do you kind of architect cloud architecture to be sensitive to where data, naturally is, and be able to do compute and get insights in the right places.
Well, that's great. So for those in the audience watching today, if you've not heard it before, you heard it today, first time from Hillary, data gravity. So David, over to you. What do you have?
Yeah, and first of all, I apologize that my video is yellow. I don't know if I can try to fix that in between people talking. It was great when we practiced, but anyway, I think, first of all, with Edge, I think the other thing that's important to understand is that's where the data is in a lot of cases, right? So you have to get out to the edge because that's where your data is going to be. And, design pattern that we're seeing a lot, and other folks have touched on it, is that you train the data back in the cloud. So you get the data that you need for training and you put that back to the cloud, as people were saying, where all of your hyperscale processing is. But then you can ship the models that you've trained out to the edge. And those models can be very efficient. They can run on lots of devices. They can run in, they can run in drones. They can run in very small devices. We're doing things at Microsoft where they can run in cameras, for example. And so then you can go ahead and do real-time decision-making at the edge using those models that you've trained in the cloud. So I think that's a really good pattern that combines those things. And autonomous vehicles, of course, are a really good example of real-time decision-making, because the autonomous vehicle has to make many, many, many real-time decisions in order to operate. But you can even think of other devices that have real-time decision-making in them. I mentioned cameras, for example. You want a camera that maybe, if it sees something suspicious, can automatically flag something. You don't want to have to send that back to the cloud first for analysis. So I think I think one common design pattern, and there are a lot, but is this idea, again, of training the data in the central cloud and then shipping the model out to the edge.
That's interesting. My car learned how to stop at a stoplight and a stop sign last month, so.
I hope you knew how to do it before you started driving it.
Well, I knew how to, tell the car to stop.
But think about the power of that for our military capabilities, right? If you say, this is all about tempo, right? And there's a saying in the Air Force, speed is life. And so I think about, what is the upgrade time now, right? For F-35, mean upgrade time for software updates is 2 years. Your Tesla is getting new capability every month. For us to be competitive in great power competition, we have to think about not, block upgrade capability, but trend of capability, velocity of capability increase. And in algorithmic warfare, right, it's really algorithm on algorithm, network on network. How fast can you fight your network against your adversary network? And that is really a question of exactly what David and Hillary were talking about, which is, what is your cadence and rhythm of ability to patch, respond, the OODA loop of fighting the network and pushing out new capability? And so to be more specific about the military use case, right, to Hillary's example, we're talking about how quickly can you detect a radar signature in the field, retrain your model for electronic warfare, and get that new waveform back on the pod, on the wing, on the bird. And do you want to have to do that commercially, disconnected? Is that being ported back, CONUS, OCONUS? What is your capability in theater? This gravitational field of data is a really powerful idea, because now data is such that we now can talk about the physics of cloud, which we never had to do before. When we were thinking about pushing knowledge worker generated data on workloads in the United States, right? It doesn't require an understanding of the physics of generating the compute. But now we have to think about this in an austere conditions, maybe in Arctic conditions, or in super hot desert conditions. What does that mean for my data center heating, cooling, availability, uptime, maintenance? Because we're talking about data at such scales that we're pushing to this new level. And it's now, now it becomes life and death, because we're talking about creating warfighting systems that are dependent on data refreshes to be stealthy, or to not, to not be observed, or in the example that Scott gave, to operate autonomously, safely, and ethically. And so it's a really, really exciting time to think about, how DoD is going to adopt this. I mean, that's why I think, the relationship between DISA and JAKE, for example, the Joint AI Center, so crucial for understanding, what are the service level agreements we need to be able to have the resiliency in our cloud to do both the, time critical knowledge work decision making of our leadership, and also to be able to be, fully disconnected, and to protect our warfighters with those capabilities. It's really, really exciting.
I would just say that I learned another term, maybe familiar to you all, but algorithmic warfare. Get my tongue tied there on that for a second, but it makes total sense, to characterize that the way that statement does. There's humans behind that creating algorithms, or machines creating algorithms that are fighting each other, and that is absolutely fascinating to think about it in those terms, to fight at that speed in that kind of complex environment. So Scott, any thoughts on what we've talked about so far? You started this whole conversation on autonomous vehicles.
Yeah, I was considering, what's been said, and I thought about the algorithms, and a lot of times those algorithms need to be shared, right? I mean, they might be the same algorithms in the cloud that you're running, on the edge, right? And I think what the mission partners and the people on this call need to consider is, have your cloud service provider or your consultants or whatever adopt things like cloud native standards, right? So those workloads can be, migrated to the edge and run there, right? Make sure that the edge platform supports these standards, right? And I think that's been a really exciting thing, technology within Oracle and our cloud is just, learning about these cloud native standards, and the fact that I can deploy something on multiple platforms and maintain it in a single location. So I think if people understand to implement these algorithms and these services in a cloud native way, using these foundational standards, that I think it makes it easy to kind of migrate them wherever they need to run.
Yeah, we talk about build once, deploy anywhere, as being kind of that catchphrase on needing to have a platform decision and then a set of coding standards and architectures. And if you do that, you can build once and deploy anywhere.
Yeah, like measure twice and cut once, build once and deploy anywhere.
Mine's measure twice, go to Home Depot twice.
Hey, my wife is out of town, and I put a bunch of shelves up and stuff on the first floor, and she has no idea when she comes back. But I've rearranged the whole first floor while she's been gone, and the idea here is if she were here, she would have an opinion. So the idea here is to get it done before she comes back, and I'm done. So we'll see. There'll be a surprise for one of us or both of us when she gets back. Anyway, so off to the Home Depot piece and back onto this discussion about algorithmic warfare and data gravity and
Can I build on some of the things we've been talking about? Maybe take it a little bit into an AI direction, because I think it's related, and actually it came up with made me think about it when you're talking about your Tesla learning to stop at the stop sign. Right? One of the challenges with training, whether it's for autonomous vehicles or really any models, is making sure that you have the right data sets to do that training. And so you can imagine you really don't want to train an autonomous vehicle by having it run around and not stop at the stop sign until it learns how to do it correctly, right? Because then it might be crashing into things. And so there's a really promising kind of trend that's happening around the synthetic generation of data that I think plays into all of this, where you can use like video game technology to, and all the compute power we have in the cloud to now take some data that you've collected and generate variations of that, which you can then use to train. And that works for autonomous vehicles. You can have them drive around simulated environments, but think of something like in conservation, where you have cameras out and you want to count the population of a certain animal. You get a couple of photographs of that animal, but you need to have it in different day-night conditions, different seasons, all kinds of things, which you may not have. You can synthetically generate all of those now different images, which you can then use to train that camera. And what that allows you to do is now take AI that's not just based on these very broad data sets, but are based on very specific data sets, very specific to your particular organization or mission. So I think that's one of the reasons that I'm so optimistic that this AI is going to continue to grow and these scenarios are going to continue to grow. It's not like we've peaked yet. I think there's a lot more ahead of us.
Great points. Anyone else want to talk about AI and where that's headed?
You know, I wanted to jump off on that and relate back a little bit to what Scott was saying about kind of the accessibility of analytics and AI. One of the things that cloud-based and public cloud services enable are to sort of put those tools in the hands of people who are not, deep mathematicians and in AI background in AI science, and the kinds of things that David was just talking about in the sense of ability to expand out data sets so as to get better, resolution on models and better capabilities and things like that. We refer to those as auto AI or auto machine learning kind of capabilities. I think there's another interesting piece of this as well, which is, we did some projects referred to as AI open scale that were intended to analyze data and determine whether or not there was bias in it. And I think, for these kind of field applications and mission applications, it's so important because out in the wild, there's going to be a very, very wide variety of circumstances encountered. And in the same way that, for other reasons, we may want to ensure that there's no, racial bias or something like that in data. We want to ensure that, out in the field, that a wide variety of things have been considered. A wide variety of circumstances have been taken into account. And so we created tooling that enables assessment of how broad was the data. Was it really representative of all the conditions that need to be taken into account? And therefore, are you sure that the AI is as robust as it possibly could be? And those kind of things I think are really exciting because they enable kind of that accountability in how things are created and enable the end outcome to be better because that you've considered a really wide variety of circumstances.
Hillary, a long time ago, it feels like I worked in the insurance industry, and we were a data organization. We were, we gathered data from all the different states, and the so what there is the data had to be clean, homogeneous, uniform, so that we can process it. And then we had a team of actuaries, highly paid, manual AI, I guess, in a way, to try to predict, future, predict how much a broken arm or busted limb would cost, or how much a death would be worth, future value. So, in my mind, that was the manual way of trying to, think about the future, right? Mm-hmm. And AI helps us to think that there's a whole lot more than just that. In the Defense Department, holy cow, if you want homogeneous, clean, uniform data, it ain't going to happen.
Correct.
And my sense is that's probably all around the world, unless you're trying to, do financial predictions or life and death tables, et cetera. So how do we get to a point where we can use data without having to clean the heck out of it all the time? I mean, is there some sort of sort feature, a filter feature? I mean, how do we get there?
Absolutely, yeah. Yeah, no, I mean, no, it's really incredible. I feel like we're so blessed to have such a huge research organization. We've got thousands of PhDs that are sitting around worrying about the kind of stuff that you're bringing up, right? How do you cleanse data? How do you automatically process it? How do you put tags on it automatically, right? They, and all that kind of thing. And that's going back to the cloud conversation. That's what's so exciting about cloud, right? Because in cloud, we can take the latest in research and someone comes up with an algorithm to scrub things better. And we can integrate them into the AI and machine learning and analytics services available in the cloud right away. And so, yeah, I mean, there are people working on scrubbing and tagging and ensuring, consistency across data sets, and that science is always improving. We would all always like it to be better than what the state, current is. And, in cloud though, because it's as a service, it can be updated and refreshed, on a very regular basis. And so cloud creates this really short time between innovation and the best of, the world's mathematical capabilities and then consumption, because the APIs that you're using in the cloud, that AI and analytics function you're consuming from the cloud provider, is and should be up to date, to the best of their current capabilities.
I think Josh was going to say something.
Yeah, I just thought it was such a great point you made, because I just remember how many boards and committees at meetings I went between agencies debating which data standards they were going to use, because nobody wanted the human burden of having to refactor their data. And so years of progress were lost. And I'm sure you saw this. Years of progress were lost with the services, for example, debating with each other who is going to have to adopt whose data schema. You could almost describe it like the data schema wars inside. And, that just really underscores the challenge of adoption, because so many things that are really feasible and mature technologies turn into not a question of how do I apply this commercial technology, but it's a question of how do I meld and adapt cultures to get used to understanding the rapid rate and accelerating rate of new technologies that are available. And so, I remember shouting into the wind that no one at the table had to agree, because we could just ingest all the unstructured data. And just if you agreed to some, common translation schemes, you wouldn't have to do this. And, I feel like today that's really well understood in the leadership of the department, and 5 years ago, it just was not. But the unstructured data ingestion and making sense of it is table stakes for all of our companies now. I mean, we call it Doc AI. I'm sure every company has a version of it. Hillary described hers. But being able to ingest voluminous quantities of data that's extremely dissimilar and make sense of it and make it useful is built into the capabilities of modern commercial clouds now. And my hope is that changes the conversation in the department towards higher value topics, because we can automate so much of that now. And it's just moving out of I would describe the ERP mindset into a question of like, how do I get all the data in one place with APIs on top of it and let people write apps that answer their questions. And it's that app development capability that you're seeing growing now it's where the conversation has moved. And whether it's Kessel Run or it's Kobayashi Maru or Space Camp or Bespin or Defense Digital Service, the conversation in the department has moved to the app development, the web app development on the data layer. And it's getting all that unstructured data into that data pool or lake, it's sometimes called, to make it available to warfighters to write the apps on top of it, is where the innovation discussion has moved.
And I'm not going to get into this conversation today because it could take up another hour, but I'll just kind of throw it out there. What if today, we decided to develop, what we called 5 years ago an ERP for whatever system or systems, because 5 years ago, we weren't building it in the cloud, obviously. And if we were to build it today, we would build it in the cloud native. And how might that be different than what we have today? But we're not going to talk about that today. That's a whole different can of worms, but you kind of brought up the topic there, Josh. Thanks. But I want to ask Scott, though, because you mentioned something, Josh, I thought was interesting. That was adoption, right? And so, Scott, why don't more people, why don't more people adopt newer technology that's available? Why is it so hard to get off legacy stuff?
I think that part of the problem, we talked about this the other day, was understanding the taxonomy of cloud, right? The lexicon, if you were, right? They're like, okay, well, what do you mean by a service? What do you mean by a tenancy, right? These are all new concepts to them. What I've been trying to do is, particularly with a lot of our hardware engineering expertise, right? Is to explain to them. I said, and that gateway is still in that gateway, right? I said, there's a computer, there's memory. The difference is you can't hug the rack now, right? But what you can do is write a Terraform script and have a complete row of racks, if you will, running your workload, right? And so and then you couple that with the fact that there's multiple CSPs out here, and how are all the names of these different things the same, right? So you have to educate them on the lexicon of cloud, and then how the cloud service providers are the same, right? As far as what they call different service, And so I think that was the biggest thing is make sure you get them into a foundational training class and explain the concepts and how they're really not much different than having computers on premise, except for, you're able to actually deploy these very quickly and not have to go through procurement and setting up power, space, and cooling and all that, right? So that's how I would present it to them.
Is there an analogy that might resonate that already exists? So for example, I use the analogy of my driving a Tesla versus my old car, legacy versus modern, to a smartphone versus a BlackBerry, right?
Yeah.
I use that to kind of try to make the point that I can relate to a BlackBerry, I can relate to a smartphone. Is that kind of a difference in capability and yield
Well,
acceptance?
I mean, ride sharing, right? It's the same technology. It's a car, right? The way you interface with it is though, as you pick up your phone versus going to the dealer, right? And picking out what you want, right? I mean, that's a close analogy, I mean, it's a different way of using the technology.
I was thinking of the analogy of, computing on a server in your building versus computing in the cloud.
Yeah, I think that's part of it. I do think with virtualization, I mean, we do have, lots of customers are running mostly virtualized in their own data centers now, and they actually aren't seeing their own servers anyway. I think part of it in our space is not so much getting used to the cloud as it is connecting to the cloud, right? Because I think there's lots of customers who, if they could just easily connect to it, they would use it. But just like you can't always go buy a server from Office Depot and take it into your office and plug it into your, customer network, right? Because there's rules for how you have to connect it. So I think there's also things that we need to do to remove the friction for getting connected to the cloud. And I think a lot of this gets into accelerating the authorization and accreditation process, for example. I think that can be particularly painful when it comes to the cloud. And I think with infrastructure as a code, there's lots of things that we can do to automate that process, to automatically generate evidence, for example, use pre-approved templates that make it easier. So I think there's going to be some blocking and tackling things that we have to do to just make it, especially within the defense community, right? To just help accelerate that cloud adoption.
Okay.
And let me just say, if I may, for a moment, thank you, David, for saying that. And I could not agree with you more. That is such an important perspective to bring up. Like, these are not technology challenges. These are human, organizational, psychological, bureaucratic challenges, right? All of these cloud providers have tools that are useful. The difficulty with adoption is not a ones and zeros issue. It is the friction that David described. And I think figuring out how to work with Congress and the department to reach an agreement on how to accelerate some of those processes is how we speed this up. But there's a lot of capability out there that has not been easy for warfighters to get access to.
Now that you're on the other side, Josh, you may understand the frustration of knowing what's available and knowing what's available to get.
I mean, I promise you, I mean, I appreciated the distinction on both sides of the equation, and you do too, because of your smartphone and your Tesla and all the other things that you described. And I think, just to talk about it at a human level, the cognitive dissonance between what our service members and our public servants have access to in their work environment versus what they have access to at home is painful for them. It's difficult for them. And I've met young enlisted folks who used their Xbox, use the GPUs in their Xboxes to play around with neural nets, for experimenting in the field, and doing stuff that they would never have the ability to do with their government issued kit. And so they know what the capabilities are. There's a lot of amazing software talent in the department that doesn't have the opportunity to use their gifts because of that friction. And I think that is a retention issue. I don't want to go on forever, but I'll just tell one story. It's a sea story worth telling. I remember being at Quantico at the Marine Corps Innovation Symposium, the second ever Marine Corps Innovation Symposium, and 300 Marines in the room. And I asked them, who, by show of hands, who's ever written a line of code? Just a line of code, anyone. Half the hands in the room went up, because these are all the early adopters. They're hungry, they're enthusiastic, they're passionate, right? They want to do this stuff. Half the people in the room, most of them self-taught. And then I asked the question I always ask next: how many of you have ever been paid by the Marine Corps to write a line of code? Not one hand went up. And so it's really getting beyond the have not to making these things universally accessible. And these are all cloud-based tools, but there are these artificial barriers that David described. And like all of us, I will speak for everyone. I will give myself that liberty. All of us are so passionate about getting these tools and capabilities to these young men and women so that they can prosecute the mission with their natural gift they've learned from birth as digital natives. And they're handcuffed, and we have to unhandcuff them.
Great point. And someone in the audience was saying, preach, Josh. And shout out to GPUs. I would just say, though, I'm glad I am not writing lines of code. I remember learning Fortran 30-something years ago as my introduction to computers, and doing do loops and thinking, oh my goodness, man, this is not going to be my life, doing this stuff. But I'm glad that there are people that are very passionate about doing that today, then and today as well. We do have 2 questions in the chat on the Q&A window. I don't know if anyone wants to jump on those. How much effort is required to train custom models by using cloud computing and hyperscale supercomputer computing? Will it incur more compute costs? If so, will auto scale and data gravity be enabled to help to offload computation costs? That sounds like a training question for David or Hillary.
Well, I mean, no, so clearly training does require a lot of processing power, which is why I was saying earlier that the training happens probably back in the hyperscale cloud. But the good news is the processing power the cost of processing has decreased so much. And I mean, that was one of the first kind of barriers that went down with cloud. If you think about what the constraints that you have on computing, it's processing, storage, and bandwidth. And processing and storage, they're effectively unlimited now. I mean, obviously you still have to pay for them. So I think you'll continue. Yes, it requires a lot of processing power, but I think you'll have that ability to do it in the cloud. So the real key is, how do you get the data back? And I think some of these edge architectures where you can do store and forward, I think things we didn't really talk about, but like 5G, even satellite communications, new communication paths, solving that bandwidth problem. I think there's going to be, so yes, it is going to require a lot of processing, but I think there's a way to get the data back to where that processing is and do the training. And then, as I said earlier, ship the model back out to the edge.
Yeah, I think there's.
Go ahead, Hillary.
Oh, sorry, I was just going to say, I think there's exciting advancements in also areas to the question about like how much is centralized versus not. There's a whole area of AI called federated learning. And one of the things we haven't talked about on this panel directly is sort of like security or data security. And with regard to, adoption of cloud and such like that, absolutely people issues, process issues, certification issues, but sometimes there's just some core and sometimes legitimate concern about sensitivity of particular types of data. And for those kind of cases, this whole field of federated AI is enabling data to kind of stay exactly where it's at, don't send it anywhere, and learn from it, and then aggregate that back into a central model. And at the same time, there are technologies in the cloud now, confidential computing, secure enclaves, homomorphic encryption is something that everyone's always kind of been waiting for it to mature, but in some ways it has for certain types of use cases. And so being able to trust and do model development in the cloud, not only at large scale, but also on very confidential data sets is also possible now. And so I think sort of the dimensions of flexibility have really improved significantly over the last couple of years.
Yeah.
That's great to hear. We have, I think, 3 minutes left. And so let's kind of go around the horn. Tell us something interesting, funny, something that we don't know, or 30 seconds each. So Dave, over to you to start to close this out.
Oh, okay. Yeah. First of all, just to kind of tag on what Hillary was saying too, another point that's a really good one there is you don't actually have to train the models. I wanted to get this out, sorry. You don't have to train the models all over again, right? So you can have a base model that's been trained on a broad set of data, and then you can kind of train incremental models on top of it. So I think she's absolutely right. There's lots of ways of training models. It's not all just one big approach, but I mean, I think there's a lot of advancements that are happening. I think, 5G, that's one we didn't talk about, but that really opens up. I think that solves the bandwidth constraint problem potentially. I've been really excited about what we've seen in terms of just video game streaming, right? Google, Microsoft, others, very graphic intensive, very latency sensitive, and works really well, amazingly well over 5G. I think that's going to enable a lot more of the science fiction types of scenarios where you can project your presence out to remote locations. So yeah, I really think we're just kind of on the beginning of all of the, solving all these problems that have seemed to persist forever in computer science. So the future is very bright.
Well, no doubt, gamers make us all better.
That's right.
I got this microphone here that people laugh about, but if not for the gaming community, I probably wouldn't have that fancy microphone so that I could do this, this session today. Scott, over to you.
Yeah, I was just on the Q&A question. I think one of the things that one salient point of the cloud is to do the training. You don't have to have those servers running 24/7, right? You can have that compute run the training and then go away, right? So it's different than on-premise in that regard, right? It's use what you need when you need it. Just interesting things, just interesting stories. I think the edge use cases for the military a lot of the cloud service providers are going to be ferreting those out, over the next few years. We did an exercise with the military just recently with our edge device, and we partnered with companies that did biometric authentication, satellite communications, right? And we were testing things like, how can we ensure the protection of that data in those edge use cases, right? And so, I think some of the other, of the CSPs and representatives on this panel have probably participated in similar exercises and have technologies to bring to bear. So I think that the customer base is going to benefit from a lot of this research that's going on.
Great. Hillary, to you for your closing comments.
Yeah, at the beginning, I had the provocative question of what is cloud, maybe to offer a definition, which you asked earlier for, cloud enables global reach, global scale. It enables that hyperscale flexibility of computing that we just heard about. It enables a freshness of content. So the latest in AI capabilities, IoT, all those other kind of capabilities are come to life because they're available as catalog functions and services. And I think the interesting couple of trends that we talked about here are distributed cloud, where we can enable that catalog of capabilities to land on infrastructure even outside the public cloud, have a platform that's consistent for building capabilities once and deploying them across all the places that IT needs to be. And then ultimately data. We talked a lot about data and the gravity of data, meaning that you want to have cloud and compute be in different locations, but also data protection. And I think, to the earlier comments, it's exciting times in cloud because we can do confidential computing and secure enclaves and things like that. In public cloud, we can distribute cloud out to more sensitive locations. And so I feel like all these pieces of compute, data protection and such really are coming together, and there's tons of opportunity in this space.
Well, great. You know what, one of the things that comes to mind to describe back to my point about an analogy, maybe I don't have an analogy, but it takes away the constraints that you have on-prem, right? It's like free, field running, versus stuck in a box. So not quite there yet, but, it helps to describe, I think, in simpler terms for someone like me. Josh, the preacher, your closing thoughts.
I want to make sure everyone gets their questions answered. And I saw there was a question in the Q&A we didn't answer about FedRAMP. And so I would say, I do not share this anonymous poster's assumption that FedRAMP is a foundation to build on. And I will just leave that as my is my parting gift here. I actually think that there are whole new architectures for security, like Zero Trust, which our cloud happens to be built on organically, that offer a different schema for security that I would argue is more compelling. And FedRAMP is just obsolete in comparison to understanding the rapidly advancing frontier of how we do security. And I know that the intentions and the original purposes of these compliance regimes were strong from they began, but to the point that David made, it's a really rapidly evolving field. And I don't think that FedRAMP keeps up. And the barriers for innovation that creates are really significant. And like the big CSPs, all the billion-dollar companies on this panel, we will figure our way through. But the 500 AFWorks companies and the 100 DIU companies and all the venture-backed innovation and all those small companies that you want warfighters to have access to, none of them have 3 years and millions of dollars to go through FedRAMP High. So, you know, maybe we'll figure out a way to get through it one day, maybe, but the rest of the innovation ecosystem never will. And so if you want warfighters to have innovation, you're going to have to revisit FedRAMP one way or another. I would argue the sooner the better. And I will leave that with you, sir, because I know DISA has a lot to say about the jab and how that works. So that will be my parting provocation for our next panel with AFCEA. Thank you for having me.
Almost feels like a part 2 in the works for this discussion. But anyway, we're at time. We're actually a few minutes over time. But, you know, 70-something participants hung on beyond. And so, I want to say thank you to our esteemed panel members, Hillary, Josh, David, Scott, for the great conversation we had today. And thank AFCEA Central Maryland chapter for inviting us and hosting us today for this great discussion. A lot of fun. And I'll start off with, Scott and his, idea about talking about autonomous vehicles. So we will wrap it up. Back over to John.
Thanks, General Yee. I think Devin, and thank you to all the panelists. Gary, you want to pick it up?
I think we're turning over to Devin now to go to breakout rooms where we continue this conversation. I really appreciate all the stories, and now I may have to go look at a Tesla. Generally, can you tell my wife that you directed me to do that, and it's a requirement?
Absolutely.
Okay, thank you, sir.
I'm definitely getting the Cybertruck.
There you go. So I'll turn it over to Devin.
Yeah, great talk today, everybody. And it doesn't have to end here, right? We're going to host a networking session. So please hop on over there. You're going to get to that through the same web portal that you use to join our webinar at the lunchtime, right? So just, you can close out of here, go back through the SWUGO link, and I'll post it in the chat below. Get back over there and you can join the networking session to continue the conversation. So let me post that there for you guys as you get over there. Check out that link. Oops, I sent that to John. That was not where I wanted it to go. Try to get it to everybody. So hit that link as you exit. Thank you all for coming today. Great chat. I'll hang out 1 or 2 moments, give you a chance to click on that link, but it'll just take you back through the same registration page. Just another 30 seconds or so, and just to copy the link or exit.
Hey, Devin, I'm gonna hit
You're
the
still
road.
hanging on out there. Don't forget, if you signed up for trivia night tonight, we have that going on. What's that?
I'm gonna have to hit the road, but thanks for having me here today.
Okay, that sounds good. My connection is bad. Great having you on. All right, everybody. See you over in networking with Rebecca. Take care.